I don't know if you guys heard Jack's question. He wanted to do this indefinite integral. The reason why I think that that's a mistake is because when you get to this, like if you try to do the antiderivative of root log t, and presumably that's all well and good, like that's set up just fine, you're going to run into some massive issues with how do I actually find the antiderivative of that. And that's why I put in here somewhere up above where this is an example where the calculator, the whole Math 9 thing, is super useful because there's just no way this is not going to happen. We could use a power series later on to find this antiderivative, or at least an approximation for it, but we are definitely not going to be able to find the antiderivative of it. So you have to use a definite integral to do this. Maybe it'd be better if I showed you. So here is like the really useful form of the fundamental theorem is this. Hopefully this will make sense. Oh, and this should be, there is a small typo on here, sorry. Instead of f of x, or f prime of x, this should be f prime of t. Sorry. That's a typo. Okay. So anyway, here's what I would recommend you do, is it would be to say the definite integral from 1 to 5 of f prime of t dt. So veterans might recognize this language that I'm going to use here, but I set up this definite integral, and isn't it pretty obvious why I'm doing the integral of f prime? I'm trying to get to information about f. But somebody might really question, well, why on earth did you pick the 1 and the 5? Did you just like pick those out of the air, or was there a reason? Why would I pick those?
Well, because it gave us those.
Well, one of them it gave, right? It told us that f of 1 is 3, and so that's why I would, go with that one. Why would I have the 5 in there? That's what I want. That's what I want. I know f of 1. I don't know f of 5. And so if you're ever setting up an integral to help you find the value of something, one of your limits better be the thing that you do know, and the other one should be the thing that you don't know. If you set it up like that, you'll set yourself up for success. And here is how the right side of this 2b equation will go. I want to see if this makes sense to you. This is the full fundamental theorem of calculus kind of in one statement. So I've found the antiderivative of f prime, and I've evaluated it at 5, I've evaluated it at 1, and I've completed FTC by subtracting those evaluations. Forrest, your question. Can I just do a what? No, that's what I was talking about earlier. Like, good luck finding the antiderivative of root log t. We'll get back to you in a week.
So you can't find like the
I bet you there probably is a closed form antiderivative, but I also bet you it's way more complicated than you imagine.
Can I just do it on my calculator, or just do like?
You have to be able to do this stuff. Probably not.
Can I just write like antiderivative of log something, and like not writing like the exact number?
No, we're going to come up with an exact number here, and we are going to use the calculator. We are. We'll get to the calculator. This is kind of the only way through this one, I think. Your question, Julia or Meg, you had a question? Meg?
I figured it out. I was saying shouldn't you do plus 3, but I think that's what you're going to get to because you'll add f1 to this.
Well, f of 1 is 3, right?
Yes.
And so I think that this statement is true, right? And I do, as you said, know that f of 1 is 3, right? And so then the question becomes, how on earth are we supposed to deal with that left side? Because we still, and we're going to leave this class other than a power series, not knowing how to do this antiderivative. So instead of trying to figure out what the antiderivative is, we use Math 9, right? Yes, we use Math 9 on that left side, and then, as you mentioned, we just add the 3 over to get to f of 5. Does that make sense? So use Math 9. Let's go ahead and do this. Let's practice this. Use Math 9 to evaluate the left side, then just go plus 3, and you should get there. Justin, it looks like maybe you already did this. What'd you get?
I got 5 point, when you do all of it.
Yeah, final answer.
5.561.
5.561?
Yeah.
Okay. So 5.561 approximately equal to f of 5.
Yeah.
Anybody else agree with Justin on that specific value there? Yeah? Okay. Good deal. So, like I said, this is a situation where FTC, this form of the FTC, the full form here, can be very handy, and clearly the calculator's capability with Math 9 also a very handy skill to have here. Okay. Cool. So we're going to do a little skipping around here. I'm going to try to keep things as pertinent as possible. I thought we would do a little skipping around. We'll come back to some of these. I would like to do the gravel pit question. Gravel pit. This is definitely calculator active. And we've done bits and pieces of this. I think veterans maybe, we probably in April of last year for sure saw at least some of this. You probably don't have the answers memorized, and that's okay.
They really got them.
I would like to say this. I want to focus you guys on something, and if you end up being kind of faster than the average student in here, and you get done with these two things I'm going to have you do, and you want to do the other ones, you're welcome to do that. But I want you to focus on the stuff that really has to do with what we're doing. So I would like for you guys to focus on part B and part D. So parts A and C are really good. They're more of a review thing, which probably would be useful to do. But I want to focus on the stuff we need to focus on, the newest stuff, I guess. So that would be parts B and D. And I don't think you need A and C to answer B and D. So please start off with B. I think that would be wise. And then if you have time, get on to D. And if you have more time, even try A and C. So, Meg, I'm sorry. No packet today.
No. But I can read it from here, which one?
Trying to
No, this is
make
good.
it as readable. That's readable. Let me.
Don't worry about it. No, I mean, I have to.
There we go.
Those are requirements.
I have to admit, if you gave me a quiz on Drake, I would get a 0 out of 100.
Hey, that's all right.
I don't.
Because I'm sure if I gave you a quiz on somebody else, that you'd get 100 out of 100, and that'd be great.
Perhaps. I just don't. I'm not up on. I know who that is, but as far as the specifics, I don't know.
So it take what?
Drake.
Do this. So
Mostly, I know him as the crazy Toronto Raptors fan,
I mean, that's fair, though.
which I know what else he does, but I can appreciate he likes his team.
The
He
six
does
god,
some stupid
Champagne
stuff.
Poppy, Drizzy, six god. I'm a big six god.
So let's look at B. So I think a couple of key words and ideas in here says find the total amount of unprocessed gravel. And then to me, as far as how you handle this, maybe the most important word is arrives. So if all we're talking about is the amount that shows up, what don't we care about as far as this part of the question? The initial amount, what else don't we care about? How much is leaving, right? How much is getting processed and leaving? We don't care about any of those things. We only care about how much is arriving. So I would say that our setup would be the integral from 0 to 8 of g of t dt.
Let's just be 100.
Oh, we need to talk about that.
Crazy.
You're not crazy, but that's not right. Anyways, you guys okay with that setup? We're finding the total amount that arrived at the plant. Jack, that's worth all of us talking about. It's okay if you guys are talking about it, but no, we'll address that for sure. So at this point, we don't bother with any kind of fancy antiderivative attempts. It's going to be ugly regardless because of that cosine of t squared. T squared really makes that a mess. So we would turn immediately to our calculator, Math 9, get it all input in there. And is it 800 and something? Did I see that right? 825? You guys all agree with that? Okay, so we say this is approximately equal to 825.555 tons of unprocessed gravel arrives at the plant. Now we know that during the day that some of it's leaving, it's getting processed and leaving, but that's how much arrived. So sometimes people will mistakenly try to incorporate the 500. I've seen a lot of people go 500 plus that and get 1325.555. That's not how much arrived because the 500 was there at the beginning, right? And so we don't want to include that in the how much arrived. That would be more of a how much is there, although if you did that, you're ignoring the fact that some of it left. So be careful with the wording.
So is 825.55?
I think so.
Okay.
That sounds familiar to me, and everybody seems to agree. If you got this set up, I agree with that part, and as long as you did the Math 9 right, I think we're good. Okay, and then D, unless there are any other questions. Okay, so D. I will do this. So D says, what is the maximum amount of unprocessed gravel during the hours of operation. So here, it's not asking how much arrived, it's not asking how much left, it's saying how much is there. So now, do you see how the 500 might come into play at some point? Because the 500 was there to begin with, and so whatever gets added or subtracted, well, the 500 was there. So now we need to think about that, and we need to think about the rate coming in as well as the rate going out. So here's what I would propose for a start here. If we're looking for a maximum, what are your candidates for maximums? Critical points and endpoints, and sometimes the endpoints get dismissed because there are no endpoints. But we always want to say endpoints could come into play. And because we're talking about during the hours of operation, the endpoints will come into play. They definitely will. The endpoints are, once you realize that, the endpoints are easy. They're 0 and 8, aren't they? So maybe I come over here and say, I'm going to make a little table here where I've got T, and then I'll just put like maybe amount which stands for the amount of gravel. You could label this in a number of ways. This is one way. So the endpoints are 0 and 8, but there could be some interior critical points that will matter. Critical points are places where what is happening? Yeah, derivative equals 0. Isn't it true, though, that aren't there kind of like two derivatives at play here?
Yes.
One of them is the rate of gravel coming in and the rate coming out. So I would say that this would be my net rate, G of T minus 100. And I know there's a temptation to put something else, and I would put equals 0. Jack, don't say it. Does anybody else know that it's going to be tempting to put something else right here? People will often want to put a T right there, but let's talk about why that's not correct. What are the units for G of T? What's the unit for G of T?
Tons per hour.
Tons per hour. So tons per hour minus, what are the units for the 100?
Tons per hour.
Tons per hour. So as it stands, this makes a lot of sense. You're doing a rate minus a rate, and you get the net rate. If, however, you did decide to put the T right here, then that means we're technically multiplying units-wise by hours, right? The hours would then cancel out of the units, and you'd be getting tons per hour minus tons. We're kind of back to that little scenario where the police officer pulls you over and says, sorry, you're going 65 and a 40, and you're like, but I'm only 3 miles from my house. We're comparing apples with oranges here. You can't compare rates with amounts or amounts with rates. They're just two different things. It just doesn't make sense. I think I know why we are tempted to do that. It's because back in algebra class, all of the rates were constant, and we were only ever interested in the final amount. And if you've got a rate like ice cream cones per hour, miles per hour, you have to multiply by T to get to that amount. So we're just in this habit of like, anytime I see a constant amount, I'm immediately transported back in time to algebra, and I just multiply whatever it is by T. I would question you with this. If we are so interested in multiplying the 100 by T, why didn't we multiply the G of T by T? Because that would be the same kind of thing, wouldn't it? I think it's because the 100 is a constant, but regardless. Jack, does that make any sense?
Yes.
Okay. So then, obviously, you can see that that is a fairly complicated equation. Strongly suggest you turn to the calculator to solve it. I peeked over Meg's shoulder, and she had 4.923 as the lone critical point.
Yeah.
Is that correct? You all agree with that? Meg, thank you for getting that right. So there are our 3 candidates. And of the 3, one of them is super duper easy. When T is 0, how much gravel is there?
500, so it's not that.
500. Well, it could be.
Oh, we didn't get to that part yet. I'm ahead of. Oh.
You could be
I'll be.
ahead of me for sure. And then here is how I want to handle the other 2 parts. At 4.923, let's think about how much gravel is there. Wouldn't it be fair to say that there's 500 plus or minus something else? So integral is right. Integral from where to where?
4.923.
Good job. And what would be the integrand to get us there?
G of T minus 100.
There you go. So G of T minus 100 times dt. Again, clearly a Math 9 opportunity. We're basically saying 500 plus whatever the change was. So if you take original plus change, you'll get the final amount. We all think, is this making sense? So you Math 9 this, what'd you get?
900, or when you add 500, it's 947.216.
You guys agree with Logan's number there? 947? Okay, so I think if you could figure that part out, hopefully then the final data point would feel very familiar, right? It would be very, very similar to what you just did. You would say 500 plus a slightly different integral. It would be 0 to 8. Yeah. So 0 to 8, same integrand, g of t minus 100 dt. You throw this into Math 9, and it spits out a lovely answer, which Santi might have.
I got 635.376.
Okay. Does that sound right? Okay, so it's finally at this point we can say...
that's for the, wait.
No.
Never mind. No, I got 525.551 for the last one.
Oh,
I got a different number for the first one.
so this is 5,
We're
2...
just agreeing on the T, or like, the amount at 4.923.
Yeah, I got a different
Oh.
number.
Because I got 635.
I got 600.
Oh, I'm just taking your guys' word for it. Like, I honestly don't memorize these answers because I think you guys are mathematicians. You can do it. So how many think it's 635 for the middle one? Woo, that's maybe slightly more than half. Maybe it's 635.
Sorry, guys.
Maybe those of you that got 947 should double check.
Is yours
I'm
just
confused.
G and T?
I didn't get either.
I don't know.
you not subtracted by 100?
No, I did.
Yeah?
Yes.
Are you in
Let
writing?
me try it, everyone.
We're going to provisionally say it's 635. Point, what was it, 376?
I love that initiative. So damn.
So those that didn't get that, maybe double check.
I got
Yeah, I did
it,
parentheses
so I
wrong.
was just looking.
Oh,
You did a parentheses wrong?
Yeah.
Okay.
It's okay. I love
Okay, that's why we do this. So, like, just because, Logan and Jack were kind of the first ones to offer, please don't sit there and think, well, I must be wrong. Maybe, very likely now, perhaps you're right. So, it's okay to say something. Get into like a really minor math skirmish. It's okay. Okay, so finally we can say we've considered all the candidates, and we've found the max amount. So we could say something like, therefore, the max amount is, now I could finish this one of two ways. One would be good, the other one would be not so good. What number should be at the end of my sentence here? The max is?
635.
Yep, 635.376 tons. Of course, that happens when t equals 4.923, but it's clearly asking for what's the maximum amount, so to answer with hours really doesn't make a lot of sense. Answering with tons does.
Makes a ton of sense.
Tons of sense, that's right. Okay, what do y'all think about B and D there? Plenty to think about, right? It's a good application question.
Justify your answer.
So, justifying your answer, absolutely. So, we've done that. I think our table is great justification. I think the fact that we set our net rate equal to 0 and found the only critical point, also great justification. We're not going to be using like a first derivative test here because we're looking at absolute extrema, like absolute maximum on an interval. And so I would say that the fact that we've considered all the candidates, evaluated them, and then picked out the highest one, that's a pretty good justification. I think I'd leave it at that. Good question. Anybody else? Anything else? All right. So then let's move backwards a little bit. Go away from our gravel pit. And I really debated about this morning. I really would like to do number 5 next. And I would say for number 5, the two that I want you to focus on for number 5 are A and C. A and C would be the best ones for us to think about here. B and D are good, but A and C I think are going to be more applicable.
X or T?
So this is not a typo. G of x equals the accumulation from -3 to x of f of t dt. F of t is what sometimes is referred to as like a dummy variable because it can't be x because then all the x's would be the same x and that would not mean what we want it to mean. And so t is just like some input other than x. It's very commonly a t. We call it a dummy variable because we know it's an input, but it just can't be an x, otherwise the evaluation would get all messed up. Anyways, so please try A and C. A and C. Roby. Does he still go by Roby?
Oh yeah.
Not Rodney?
Mm-mm. Nobody knows his real name. Yeah.
Well, I do. You do too.
Yeah.
We alone.
Yeah.
We know this.
Don't tell anybody. Secret.
Yes, sir. No, G and F are different. So G is defined as the accumulation from -3 to x of F, and F is that graph. T is like an input like X. But we can't have that T be an X because we already have X as our accumulation variable. So if the T was an X, if you wanted to find like G of 0, like you're trying to find in A, then you'd have to plug a 0 in wherever you see an X, and that would not be what we're trying to do here. Not directly, because you don't. Yeah, like G of 0, like I would take it very literally. G of 0 simply means
It's negative.
wherever you see an X, you put a 0.
So
Not a T, wherever you see an X,
G
you put a
prime
0.
of x equals
Yeah, so
F of
that
t
doesn't
minus
equal a 0 for all variables, it just means wherever you see an X.
because that's
You drop and divide.
yeah, drop and drive.
So you drop the x into the.
Well, actually, no, I didn't.
There's
No,
f of x.
No, I did not drop it. What
Now,
I did is G
To
prime of x
actually
equals
evaluate this, you're
um,
gonna have to use the graph. Does that make sense?
what was I doing here? I don't even remember what I did.
Because all I did is I just did, here's what I did. I did ddx of that, which means I just dropped, which is f of x. And I derived, which is 1, so it's just g prime of x equals f of x times 1. So g prime of 0 equals f of 0 times 1, which just equals 1.
Oh, I did it. Yeah, I did it instead of a derivative.
Oh, yeah.
Absolute minimum.
Oh, let's make a little table.
Tables. He said he's gonna make a table. I thought that made sense.
Tables.
You know?
So now it's g prime. So 1, 3. What?
Because G, so I think so like G is defined as an accumulation function. So we're not going to be setting up our own integrals. We're going to be using directly the rule for the expression for G of x.
Yeah, so that's it. I just got
Plug in -5, -3, -5 is
So yeah, there's no need to do this.
0.
Yeah.
There's no need to do, so like
Is this
G of 0 is defined as the integral from -3 to 0 of f of c.
Oh, I just.
And so, yeah, so I feel like you were almost, so here's the thing, like you were saying, like the antiderivative of little f was big F, right? We don't have any information about big F, right? You have plenty of information about little f, we're going to be using area. Now, if we have time to do this tomorrow, this is on the graph, because notice that this one, this is what we're looking set up, like with this graph.
I woke up this
You have
morning
this
thinking it was
information,
already
things that start with prime. At no point does it say some function is the accumulation of some other function. Whereas this one,
excited for the fact that
Yeah.
tomorrow she's
so the way that we approach it is sort of similar.
positive.
We're going to be using it as but it's a different approach.
Yeah, no.
3 to 3, it's
I'm
all
like
positive.
the person I've ever met.
You met yourself.
4 of 4, it's all good things. So there's absolute.
So if I use area here, I just need to go through and figure out what's going on from -3 to 0. And it looks like that's 4.5? If I find this area right here.
That's what I got, and I'm always right.
And
so
please be careful.
Not true.
You're right. It's
please be careful that you notice that that's above the x-axis, therefore positive. If it happened to be below, then that would be a negative 4.5 accumulation. So I'd say this just equals 4.5, and we're done. That make sense? So what I'm going to show you here next, I think, is there's going to be a detail that you probably wrote down. Maybe you didn't. If you didn't, you definitely want to do this. It wants to know g prime of 0. So let me ask you a question. If I'm going to find g prime of 0, do I need to find g prime of x and then plug in a 0, or plug in a 0 and then find g prime? What do I do first? G prime of x first. That's right. So if I'm going to find g prime of x, I would say that g prime of x equals, I differentiated the left side, I need to differentiate the right side, because whatever I do to one side of an equation, I have to balance it out by doing the same thing to the other side. And my hope is that when you saw that right side, you thought, oh, I know what that is. Yeah, the fundamental theorem, part 2. So then that means that g prime of x equals f of x, right? I want to mention to you that this connecting g prime with f, I hope you're listening, all of you guys. Writing that down is going to be kind of your gateway to showing that you actually know what you're doing. Because if you don't write that down and you start using all this information from f to do whatever it is you're doing, it really doesn't make a lot of sense. How is f connected with g prime? If you write that down, we get it. If you don't, we don't. Make sense? So it's really important that you write that down. So then I want to know g prime of 0. So g prime of 0 equals f of 0. And f of 0 is 1. Hopefully a nice, tidy process there. Does that make sense to you all? All right. So then part C says find the absolute minimum of g on the closed interval -5 to 4. So absolute minimum, hopefully fairly familiar language. Where are my candidates going to come from for that?
Endpoints.
And I got my endpoints right there. I'm going to do this off to the side so I actually have room. So here's my table that I'm starting. I've got x, and then I've got g of x over here. My x's are going to be -5 and -5 and 4, and perhaps some critical points in between, right? So where am I going to get my critical points from? Yes. So I'm going to write that in here. I'm going to say I want to know where g prime equals f equals 0.
Would we have to write it like that?
You could just write, no, great question. So since hopefully you already made this connection here. If you did, then you could write g prime equals 0, you could write f equals 0, or you could write what I wrote. Either way is fine. So then, but you do need to write the rate of change equals 0. You do need to write that down. Hopefully you made the good connection. It's all good. How many places is that true? 3, right? -4, -4, 1, and 3. I agree. So -4, 1, and 3. We need to address all those in some way or another. And there's a variety of ways you can do that. Which one, or which ones perhaps, could I dismiss very quickly as not being possible minimums? 1 and 3. 1 and 3 we can get rid of right away, can't we? For sure 1 and 3, but we have to actually address it. We can't just like erase them and say, yeah, you weren't even ever there. So maybe you say, here for 1, couldn't you say that g prime has a certain behavior? G prime, what would you say? Why is that not a realistic possibility? Yeah, g prime does not change signs. I'm going to squeeze this in over here. G prime doesn't even change signs there, so minimum can't be 1. How about the 3? Why is the 3 so bad? Yeah, g prime does change signs there, but it's the wrong sign change pattern. So I'd say g prime of x changes from positive to negative. So that's not my minimum. That would be a relative maximum, which could not possibly be the absolute minimum. So then I'm left with 3 possibilities that I might have to do a little bit of math to investigate, right? What do you think? So g of -5, g of -4, g of 4. I'm just looking here. I don't see that we've done any of this yet. So maybe we just go back over here. I'll come over here to the side. I'll do my work over here. G of negative 5. What would I need to do to handle this?
Just take the definite integral.
Yeah, do the definite integral. So it'd be from negative 3 to negative 5 of f of t dt.
Or negative 5.
Or G prime.
Did you notice? Did y'all notice that the direction of accumulation is backwards from the way we don't normally do it?
Yeah.
Wait, why are we doing that?
So it's just negative.
Because
Oh, this is a
I'm
function.
trying to find the minimum.
That's my bad. That's my bad.
So what if we did g of negative 5 really equals negative integral from negative 5 to negative 3 of f of t dt? Does that make sense? Okay, so now I accumulate from left to right. Well, that's kind of interesting because as I go from negative 5 to negative 3, don't we have two areas that are equal yet opposite signed? 0. Negative 0 or just 0? Okay, so I've got a value there. And then I could also do the same thing for negative 4. So I'd say g of negative 4 equals the definite integral from be negative 3 to negative 4. Kind of the same backwards accumulation here. So do you see how the area is 1? But because we're accumulating the wrong way, we'd have to make it negative 1. Does that make sense? Okay. So now I would say that negative 4 is my new favorite candidate, right? It's lower than the other one. And then maybe we do g of 4. I'm going to come up here to do this. There's a STEM thing at lunch.
Hi, everyone.
Love for you to
Happy
go.
Thursday.
I think that's probably it.
Don't forget to stop by the Valor Upper Lobby during
Yep.
lunch today to hear from our guest speaker, Mr. James Jameson. Mr. Jameson has had a
James,
fascinating
son of
career
James.
as a systems
James.
engineer,
Or James.
technical marketer, and enterprise architect. But Mr. Jameson is most passionate about sharing how his journey has drastically evolved through the Lord's provision. Grab your lunch and we hope to see you there.
Okay, so let's wrap this up. You guys agree with me that g of 4 is going to be 4.5 plus some stuff? And then,
Positive.
Pi over
Two minus.
so it's going to be a rectangle minus a circle, right? So it's going to be 2, and then that little half circle. Well, let's see here. The radius is 1, isn't it?
Is, so it'd be pi, it's pi over 2.
So it'd be pi, and then half of that would be pi over 2. Sure. And then how about that last little stretch from 2 to 4? Well, but it would be a positive 0.5 and then a negative 0.5. So then it would be 0. So then I'd get g of 4 equals essentially 6.5 minus pi over 2. Is that bigger or smaller than negative 1? Bigger. So we would say then the minimum is negative 1, justified by all of our lovely integrals and our tape. So anyhow, tomorrow we'll be talking about Timmy and all of his problems.